All right. Hello, programmers. This is TouchDesigner Week 11 Asynchronous lesson. This is like the fourth time I've recorded this. I had a bunch of problems. I spent a couple hours on the first version before I realized it was only intermittently recording because I was trying to use OBS Studio, which just doesn't work. So I went back to the old style of recording, and we're going to have to do it all over again. That's why it's 5 o'clock and it isn't posted yet. Sorry, I meant to have it up a lot earlier, but you know, things happen. So we'll just start all over again. Good thing is, since this is the fourth time I've done it, it should run a little bit quicker and smoother. All right, so jumping right in. These are Arduino devices. There are 3 different styles here. This is an Arduino Mega. You probably didn't buy one of these, but if you did, you should be able to make it work. This is an Arduino like V2, the kind with the little mini chip. And this is the original type of Arduino with the big long inline chip. All 3 of them any of these should work. You may have to install special drivers on your Arduino depending on whether it's a out-of-the-box compatible device or not. Some of the cheaper ones have their own USB drivers, and you may need to install those to get it to work. So if it doesn't work in your Arduino, then just search for the manufacturer of your Arduino device and the word drivers, and you should be able to find the correct drivers, install them, and get it to work. If it still doesn't work, give me a call. I've never, or text me or set up a meeting. I've never been able to not get an Arduino to work if I find the right files for it. So anyway, jumping right in, if you've never done Arduino before, then there's a few tutorials I would like you to do. If you go to YouTube and you search for Arduino Basics, here this orange one, this tutorial hardware overview Arduino course for absolute beginners by Programming Electronics Academy. If you do the first 4 tutorials there, that will introduce you to the hardware and the programming environment and the syntax of the coding, which is fairly easy. And each of those tutorials is only about 8 to 10 minutes long, so you should be able to run through all 4 of those in just a half an hour or a little bit more than that. Let's see. So after you do that, then come on back and head on over to Tinkercad.com. And in Tinkercad, it's a place where you can simulate Arduino code. You don't have to use Tinkercad, and in fact, as I'm doing this in Tinkercad, you might want to just do it in real life. I'm going to show you both, but I'm going to definitely do it in Tinkercad because it's a little bit easier for you guys to follow because the wires are nice and straight, and yeah, I can also share you the file when we're done so that you can have this as a reference. Basically, this is what we're going to construct today. You'll have your Arduino device, and the first thing we're going to do is add this little LED and this photo resistor, or an LDR, light dependent resistor. And we're going to create a circuit that makes the LED blink based on how much light is coming into the photoresistor. Then we're going to add a potentiometer, which is a twisting device that you can get different amount of resistance or a different amount of voltage based on where you have that potentiometer twisted to. And then we'll add a button. And then we'll set all of those up for serial communication into TouchDesigner and control things in TouchDesigner. And then I'll see where I am in the recording after that. And then if we have time, I will go ahead and get started on using that data to affect a blobby sphere. Okay, so let's start over on this. Let me just delete all of this stuff. How about can I just delete the entire breadboard? Or do I have to clear everything out one thing at a time? Hey, look at that. Can I drag a line around things? No. All right, well, I'll just do this. All right, so let's start with an Arduino device and a breadboard, small. Your kit should come with a breadboard. Hello, breadboard, where are you? I think it might be lagging. Bagging, sagging, lagging. Come on, breadboard. No, give me my breadboard. Nothing but problems today, nothing but problems. There we go. Oh, now it gave me like 5 of them. Whatever. Come on. Don't draw pictures. Don't draw cables yet. Just move the breadboard. All right, cool. So let me talk about a breadboard really quick. Let me actually move this away. There we go. And you go away. I hit delete. There we go. Okay, so the way a breadboard works is all of these on a row are connected together. And these here are rails. They're usually used for power. That's why they're labeled plus and minus. And they are connected together this way. So all rows are connected together this way, and all rails are connected together this way. There's also a gutter in the middle that separates the left half of the board from the right half of the board. So these here are not connected to these here, and that allows you to put like inline chips across the gutter and not have the legs on the left-hand side shorted to the legs on the right-hand side. It's also useful for buttons and anything that has 2 lines of pins. So the first thing we're going to do is we're going to want to add an LED to your breadboard, and like I said, you can do this right on your Arduino. You don't have to do it in Tinkercad, but I'm going to do it in Tinkercad first, and then I will do it in real life for realsies, and that way you get to see it twice. All right, so an LED has a long side and a short side pin, and that is that's to differentiate the anode from the cathode. And with LEDs, because an LED is a light-emitting diode, diodes only pass power in one direction. So it has to go from the anode to the cathode. And if you have it backwards, it just won't work. So if you try this on your breadboard and you power it up and the thing's just not lighting up no matter what, then it's probably just flip the LED around and it'll be fine. So I actually, for our purposes, I want to flip this component around because I want my cathode to be on the other side. So I'm going to hit this, flip this around, and I'm going to drag it down here so that we have room. Okay, so I have an LED. Now, let's see. Yeah, what I'm going to do now is I'm going to power this LED from pin 13. And I'm going to make this cable red. And so this will blink, make the LED blink when I hook it up to ground. Now, I don't want to hook it directly to ground. It would work, but it would be sending too much current to the LED, which would eventually burn it out. If you left it on for an hour or so, it would burn out your LED. So we need to put a resistor between the cathode and ground to limit the current coming out of that. So I'm going to add a resistor here. And I'm going to rotate the resistor 90 degrees. Whoops, too far. We'll just go all the way around. There we go. Resistors are bipolar. It doesn't matter what direction you put it in. And I want this to be a 220 ohm resistor. Not 220 kilo ohms. Hello. 220 ohms. There we go. And I'm going to put that coming out of here. And that's going up to pin 6. Actually, I'm going to move it down. Like that. There we go. All right, now I'm going to put from this ground wire here, ground pin here, over to pin 6. All right, and I'm going to make this black. Okay. And so this will actually blink. If you haven't ever programmed or used your Arduino before, it by default usually has the blink code loaded on it. And if you were to plug this in now, this would start blinking. But we're going to go ahead and continue on and add some other stuff. We're going to, instead of just having it blink by itself, we're going to use the output of an LDR or a photoresistor, rather, to drive this blinking. So I'm going to stick my photoresistor here. And we're going to measure the output coming from this photoresistor and use that to edit the delay time in between blinks so that when it gets more light, it will have less resistance, and that will create a higher voltage coming into the analog pin. And we're going to use that to drive the amount of delay. So the more light that hits the photoresistor, the longer there will be between blinks. Now, the first thing we have to do in order to do this is the Arduino doesn't measure resistance. It only measures voltages between 0 and 5 volts. You don't want to try to feed it more than 5 volts or you blow up your Arduino. But everything here is going to run on 5 volts because it's powered by the Arduino itself, which outputs either 3.3 or 5 volts. But like I said, it doesn't measure resistance, so we have to use what's called a pull-up resistor to create like an escape route for the electricity to go. So what's going to happen is we're going to put a pull-up resistor, which is a 10K resistor. Here, let's put this resistor. Let's rotate the resistor 90 degrees. And this is going to be a 10 kilo ohm resistor. You should have that in your Arduino kit. And I'm going to put this over here. Let's see, that goes to ground, so I'm going to put this on the same line that goes to ground. And put that on that side of the resistor, okay? So the electricity is going to come in on this side. Let's go ahead and do that. Let's put a line over here. And go all the way over to 5 volts. Okay, I'm going to make this one red. When you're actually patching this, it doesn't matter what color lines you use. It's just, I like to use red when I can for power and black when I can for ground so that I don't get confused about what's going where. But the electricity doesn't know or care what color the plastic jacket is around the wire that you have patched to it. So you can use whatever color jumpers you want. All right? Yeah, so what's going to happen is the electricity is going to go through the resistor, and then on this side we're going to measure, we have a path to ground that goes through a 10K resistor. Now if there's anything less than 10K, it's going to want to send electricity through that less resistant path. If the resistance goes above 10K, then it's going to go through the escape route through this pull-up resistor line back down to ground. And so basically the way this works is when the light LDR gets more light, its resistance goes down. The closer, the less resistance it has, the more electricity will pass through it and not go to this escape route. If you didn't have the escape route, then there would be nowhere else for the electricity to go, and you wouldn't get fluctuating values. Right? So that's how we can use this pull-up resistor to make the voltage change based on the resistance. So we're going to now, on the same path, the same leg that has the escape route that goes to ground, we're going to pass that to analog 0, A0. Okay? So now we got that patched. This should actually work when we get the code in it. All right, so now to do the code, run your Arduino IDE. And we're going to start by opening some example patches and some example code, and we're going to mix two different example codes together to get this to work. Oh, come on, Arduino. Preparing boards. Preparing. You're always preparing. Just go. All right, that's what we'll end up with. Let's make a new one. And let's also open up under examples, basics, analog read serial. We're going to use some code from that. And also examples, basics, blink. Okay, so in our new Arduino file, delete everything. Okay, then grab everything from your analog read serial, copy it, and paste it in your new sketch. Okay, and yeah, let's see. Let's get rid of this. We don't want any of this commented stuff for now. Go away. I don't care. There we go. All right. So now we're going to define some constants first. That we're going to use to define the pins that the LED is sitting on and the LDR. Sorry, the LED that is sitting on and the LDR is attached to, or is going to be read from. So let's see. This we're going to have const, which you don't really need to do this const, but I'm going to anyway because that's the way I did it in my notes. Here, let's go ahead and start commenting these the right way. So these are constants that won't change. Const int LED pin equals 13. Semicolon. You have to put a semicolon at the end of your lines in Arduino because it's not white space dependent like Python is. So you need to tell it where the end of lines are. It doesn't know otherwise. All right. Then we're going to const int LED pin up LDR pin. LDR pin equals A0. Okay. Then we're going to put some variables that will change. And we're going to have int LDR value. And we'll go ahead and give it an initial value of 0. And int LED, no, we don't need one. We don't need a value because we aren't reading the LED for this. So for now, that's all we need. Okay, then in our void setup, we need to set our we need to set up our LED pin for output. Yeah, so we're going to say pin mode LED pin output, all caps. Okay. Yep. serial begin 9600. Actually, we want to do this before we do our serial begin. So let's put it up here. There we go. All right. Serial begin 9600, and what we're going to do is, let's see here. Oh, I know what we can do. No, do we need to do that? Yeah. Int LDR value. We're also going to have int blink delay equals, let's say 10 for now. Okay. Now, here under the loop, we're going to say blink delay equals analog read. Actually, we got it here. Let's do it this way. Boom. Blink delay equals analog read A0. Or instead of analog read A0, we can say the LDR pin, right? That's what we called it because that's A0. LDR pin. So blink delay equals LDR pin. And this will read the LDR pin voltage. Okay. Then we're going to print out that LDR pin. We're going to print out blink delay. Okay. And then we actually want to take the stuff from blink here, from inside of the loop. And we're going to grab this code here. Copy that. We can get rid of this delay message. We don't need that because we're going to put in bigger delays than that anyway. Put that in there like that. Okay. So now, instead of saying LED built-in, we're going to actually say digital write LED pin high. Then we're going to delay not by 1,000 milliseconds, but instead we're going to delay by blink delay. The value that we just read, and make sure that it's at least 10. So we're going to say blink delay plus 10 milliseconds. I guess I don't really need the spaces there. Okay. Blink delay plus 10, digital write LED pin low. Let's just put LED pin in here. So it's going to turn it on. It'll delay by the amount that's red, then plus 10. Then it will turn it low or turn it off. And then delay by the same amount. Blink delay plus 10. Okay. Yeah, that should work. So let's see. Wait for a second. Wait for LDR value. All right. So I'm gonna let's save this and we'll call it hello touch example. TouchDesigner example. All right, now grab everything in your TouchDesigner example, copy, and I'm going to stick this code in my Tinkercad. So any code that might have been in the Tinkercad, I'm deleting it and I'm putting in this code. Okay? Then I should be able to say start simulation. And if I didn't make any, there we go. You can see this, it's hard to see, but this LED is blinking. And if I go here on this photoresistor and I turn up the value, then it will blink a lot slower. Okay? And if I go to serial monitor, you can see the value that it's reading from from A0. So when I put this up, when I increase the amount of light to the LDR, you can get a number that's closer to 1024, right? When I have a light that's smaller, then I get a number that's closer to 0. Also, you'll notice that the serial monitor moves faster when there's less light because we're adding a delay in our code that actually delays the transmission of the value as well. All right, so now it's time to build this for realsies. Let's go ahead and I'm going to stop my simulation over here so that it's not using as much system resources. And there we go. We're still recording. There's probably quite a bit of delay between when I put my hand there and when you see the hand, so bear with me on this delay. I'll try to wait for things to show up. All right, so I'm not going to use this one. I'm not going to use this one. I'm just going to use this one. I got my breadboard here. And let's see, what do I need? I need an LED. There's my LED. Here's an LED. So the long and short of it is that this LED is going to be coming in, the two sides of this LED, one pin is longer than the other. That's where the long one is where the electricity comes in, the short one is where it goes out. So I'm going to put my LED down here, just like I did in Tinkercad. Okay, then I'm going to need a 220 ohm resistor. Hopefully your resistors are labeled. If they aren't, then you'll have to use the code to figure out what your resistor is. And if I show you really quick, let's see, resistor color code, how this works. We open this chart here. I believe your kits probably come with one of these little cards. Come on, show me the picture. There we go. Okay. So the way this would work is if it was a 220, it should be like red, red, black, black, and then maybe a brown, right? That's a four band code. And the way that that works is the red, as you can see here, is equal to 2 in the first band. The second red is equal to 2. The third band is equal to 0, so that's 220. And the fourth band is also black, which is a multiplier, so that means you're multiplying it by 1, so that's 220. If it's a 10K resistor, it's black, no, it's brown, black, black, red, brown, because brown is 1, black is 10, black is 100, and then you're multiplying that by red, which is 100, and 100 times 100 is 10,000, which is 10K, right? So, you know, look at your resistors if they're not labeled, and if your kit has resistors that aren't labeled, then figure out what they are and write it on the paper, because it's way easier to do that way than to try to look at every single resistor. But if you get them mixed up, or you're dealing with components you've already pulled out of the paper, then that's how you can figure out what it is. So this is a red, red, black, brown, which is a 220. So what I'm going to do is I'm going to put this in where that second leg is and go to a different part on my breadboard. And that different part on my breadboard is going to be where I have where I'll use a jumper cable running to ground. I'm going to try and use a black jumper cable. But again, you can use whatever color you want. The electricity doesn't care. And I'm going to set that to ground here. Sometimes it's hard to get it in the right spot because you're looking at it from a side, but just look at it right from overhead, and you'll see that that is going into the ground. Okay? So then the other side needs to go to pin 13. And do I have a little red? Yes, I do. So this will be from this leg going into pin number 13, which is right next to the ground. Yep, that's in pin 13. Okay, so that should blink. And if you run your Arduino right now and you've never programmed anything, it usually has the blink code attached to it already by default. And so you would see that it would actually start blinking when you line it up. But we're going to continue on. And we're going to hook up our LDR. Right, so just plug in your LDR someplace that gives you some room away from these other stuff. There we go. And so, I'll bend it this way to make it a little bit more. There we go. That's easier to see. Okay, so then what we're going to do is we're going to need to use a 10K resistor to go to ground. And I don't need to send it all the way. I don't need to have a 10K going all the way back to the Arduino. This wire here, come on, delay, there we go. This wire here goes back to ground, so I can just simply send power from here back to the ground through a 10K resistor. So here's my 10K resistor, and I'm going to plug that in, going from the LDR to the same row that has the wire that's going to ground in it. Okay, so then that has our pull-up resistor escape path to ground. On that same leg, I'm going to attach a wire, a jumper that goes all the way to A0 to read that voltage. It needs to be on the same path that goes, sorry, not there on ground, on this side, on the same leg of the LDR, right? That's going to go all the way over here to A0 on my Arduino. Okay? And now we have to actually provide power to the Arduino, I'm sorry, the LDR. So I'm going to need to use, do I have a really long red? I don't have a really long red, but I have a really long orange, which is close. So I'm going to send power to this leg of the LDR from the Arduino's 5 volts. V in, ground, ground, 5 volts. Okay, so that's in the 5 volts. Yeah, there you can see it kind of in the 5 volts. All right, so that should work. So now I'm going to minimize this. Let's go into my Arduino, minimize this, and TouchDesigner example. That's what I'll be actually communicating with. And I'm going to plug in my Arduino now. So I plugged in my Arduino. When I did that, you should probably see the LED flash a couple times. And I'm going to now, under Tools, is it? Yeah. I need to make sure that here under Board that it's set to Genuino Uno, because that's what I'm using. If you had a Mega, I would choose Genuino Mega here. Right? But I have an Uno, so that's what I'm using. And then on Port, which is often not populated when you first plug it in, but I had it plugged in earlier, you'll have to choose the USB modem, Arduino Genuino Uno. Or if you're on Windows, it'll probably be like COM3 or something like that. And it usually will say which one your Arduino is attached to. You have to do that so that it knows where to send this information. All right, once I do that, I can upload this code. And it's compiling it. Now it's uploading it. Here, I'll switch back to the camera. And now you can see it's flashing. And it's so much brighter now that the sun's starting to go down. All right, and if I hold my finger over this, you should see that the flashing slows down. No, it speeds up. It speeds up because there's less delay between the flashes. When I uncover it, it slows down. And if I really want it to slow down, I can blast it with some light from my flashlight. My phone will unlock. Come on. Come on, phone. I don't have time for this. There we go. Flashlight. And now it's even slower. Okay, so let's take a look at the serial monitor on this. So if I go here and I go to Tools, Serial Monitor, and you have to make sure that your serial monitor is set to the correct baud rate of 9600, because that's what we set up. There, you can see the value that it's reading, 650. When I when I put my finger over it, that value will go down. It's not going down to 0 because the LDR, even when I put my finger over it, is getting some light that's coming in the bottom side of the LDR. If I cover the entire thing, then the value will get much smaller. Right? Also, you can see when I cover the whole thing, the transmission gets faster because it doesn't transmit when you have a delay. So we're actually going to take out the system delay in our next version before we send it to TouchDesigner. Yeah. So, next version. Back to Tinkercad. Okay, so we got this stuff. We are now going to add a potentiometer to this. So let's see, I'm going to close the code. I'm going to add a potentiometer. Oh, that's so much faster now. All right, potentiometers have 3 pins. The outer pins are the input and output of voltage. And it doesn't matter which direction you do it. That's why they don't label them anode and cathode. They just label it terminal 1, terminal 2. The middle pin is the wiper, and that's the one that actually has the varying voltage that we're going to read. So what we can do here, when you wire this up, you can just keep on wiring it up on your breadboard. You don't have to do this in Tinkercad, I'll say again, but I'm going to do it in Tinkercad first so that it becomes really obvious what I'm doing. All right, so I'm going to use this same line here that goes to ground, and I'm going to send that over to ground here, and I'll make it black. Okay, this one is going to go to the 5 volts. So I can send it over here to 5 volts. I don't need to go all the way back over to the Arduino because this is already going to 5 volts. Okay, right? So this goes to the 5 volts, this goes to the ground, and then this, we're going to read. This line here, we're going to read. So I'm going to send this down and over and up and to A1. And here, I'll make this a different color. I'll make it purple. Ooh, that looks nice. Okay. And so now, to read that, let's add some code to our Arduino. So we can close this. And let's add a constant. The constant we're going to add is our pot pin, or pot is short for potentiometer. Constant int pot pin equals A1. That's where we have that patched in. All right, I think that's all we'll need there for now. And then we're going to add down here pot value. Int pot value. Oops, let's go ahead and make it give it an initial value equals 0. We're actually going to take out the blinking now, so let's just go ahead and comment this out. Okay, we're not going to use that anymore. All right, pot value, 0. LDR value, 0. Okay, great. Now, down here, let's speed up the communication here. Instead of 9600, we're going to make this much faster, which is 11.5.200. Don't get the number wrong. It's 11.5.200. If you get the number wrong, you won't be able to get it to work right. Okay, now let's see. We are going to we're just gonna read both of these values. We're gonna get rid of the blinking for now. Get rid of that blink. Get rid of this delay. Get rid of this blink. Get rid of this delay. All right. So serial print ln. We can say serial dot print ln what is it, pot, what is it, pot value, but right now that's only going to print a 0, which is what we gave it, because we haven't done a read. We have to add our read up here. So we have blink delay equals analog read LDR pin. We're going to, and instead, well, I'll leave it for now. We're going to say pot value equals analog read pot pin. Okay, so it'll read first that, then it'll read that one. And let's see. Oh, this is where I declare that blink delay. So actually I do need this. And instead of calling it, do I need it? LDR value. Was I just not using LDR value down here? I guess I wasn't. Okay, that's fine. Let's do it this way. Instead of saying blink delay equals analog read LDR pin, we're going to say LDR value equals analog read LDR pin. We just aren't using this word blink delay. We weren't using it last time. Well, we weren't using LDR value last time, even though we had put it in there. Okay, LDR value equals LDR analog read of the LDR pin. Pot value is analog read of the pot pin. Then we serial print one, then we serial print the other. This would work, but what it's going to do is it's going to put it first on one line, then the next reading on another line, which might be hard to distinguish them apart. So instead of doing a serial print ln, we're just going to do a serial print and serial print, and we're going to put a space between it. Serial dot print single or double quote space double quote close parentheses semicolon, and that'll put a space between it. But right now we have no new line character, so it it'll just run to the right, and it will never stop, and that's not what we want either. We need to have a new line. Now you could do serial print blink delay print space serial print ln pot value, and that's the way you normally do this in Arduino. But when you actually do a print ln, it sends two different new line characters. It sends like a carriage return ASCII like 13, and then it also sends an ASCII code 10, and it's just an extra thing that we have to deal with in TouchDesigner. And so it's a lot better to just, instead of using serial print ln, you just, when you want to make a new line or when you're done with your data string, you say serial print open parentheses single quote /n single quote \n, yeah, \n single quote. It'll turn blue like that. And that'll only send the one value, and it'll be way easier to deal with in TouchDesigner, and it'll work fine. It'll work the same way in Arduino, this serial monitor. All right, so now I'm going to grab all of this code, and I'm going to put it in our Tinkercad. Okay, and if I start simulation, what happens? Void loop, LDR value is not declared in this scope. LDR value. I did declare LDR value up here at the top. Oh, I spelled it wrong. Boom, that'll do it every time. Value, let's do this over here in my Arduino. And if I had done my code, I would have found this error. There we go. Start simulation. What? What now? Function void loop, blink delay was not declared in this scope. Where's blink delay? Oh, serial print blink delay. Sorry, this should be LDR value. LDR value. And over here, let's do the same thing. LDR value. I should have just started with that, but whatever. We can roll with the punches. Start simulation. There we go. All right, now if I go to serial monitor, see now nothing blinks anymore because we got rid of all that blinking stuff. But if I go into serial monitor, you can see here's the 54, which is the LDR's value, and if I turn that up, that value goes up. And then the wiper value is at 0, but as I turn this up, it goes up to 1023. All right, cool. So let's do this for realsies now. All right, so it's still blinking away. So before you make changes to your wiring, you should probably disconnect the Arduino. That'll just make things a lot happier. Move that out of the way. I had a little sunshade there, but now that the sun's starting to go down, I don't need it. Okay, cool. It's looking good. This is moving way faster than last time. Okay, so now next thing we need to do is add this potentiometer. It looks like this, right? Where are you? There you are, potentiometer. Why don't you go away? There we go. Oh, there it is. So we're going to add it. I'm going to face it away from the other stuff and put it up at the top here so that I have room. Like that. Okay? It doesn't matter which post on the outer ones goes where. It's the middle post that matters. Right? So I want to have one going from, do I have a red? Here's a red. This wire here goes to, this wire here goes to voltage, so I can attach that to this outer pin. Looks like that's in the right place. It's hard to say. Let me try to move it so the camera can see it. I think that's right. Okay, and this here, this over here, it goes back to ground. Where? Come on, delay. Let's go. There we go. That one here, that goes back to ground. So let's put a wire between that and the other pin, the other outer pin. Okay? And then we'll use another long wire. I think I got a blue one here that's long somewhere. There it is. And we'll use that for the wiper, for the read value. I'm going to send that all the way over to A1. Okay? That should work. Let's go ahead and plug it in. Okay? I haven't uploaded the code, so things are still blinking. I'm going to go to Arduino now and upload this code. Make sure my tools still set to the correct board, still set to the correct port. Upload the code. Done uploading. Okay, you can see it stopped blinking because we got rid of the blink code. Now if I go to Tools Serial Monitor, it's on a different port speed than we did before. So it's going to spit out garbage at first, right? Because it's trying to read 11.5.200, or it's trying to read 9600, but it's transmitting at 11.5.200. So if I change this to 11.5.200, then it should give me the values that I want. You can see there's the LDR, and if I put my finger on it, that value goes down. And things are moving much faster now that we don't have those delays. We only have like, did I put a stability delay in there? I might have forgotten to put a stability delay in there. I think I did. Okay, so there's no delay. We should have at least a 10 millisecond delay here. Delay 10. Sorry, 10. Because otherwise, you can see when I start to move this value, sometimes it hiccups. And that's because when it tries to read the changing values, it's not keeping up with the communication speed. And so that causes hiccups in the data. And those hiccups will get transmitted to TouchDesigner, and it'll cause hiccups in your patch in TouchDesigner. So let's upload this again. There we go. And we are off and running. Holy schmooly. All right, so let me minimize this. Cool. All right, one more thing. We got to add the buttons. All right, so here we go. Let's stop our simulation here. Let's close the code for a second. We're going to add a button to this. Push button. There it is. So I'm going to put this across the gutter. Doesn't matter, you don't really have to do it, but the thing to remember about the button is that this post and this post are attached together. That's why they're called terminal A1A and terminal 1B. They are attached together. So if you sent something over here, if you sent power in this side, it would come out this side, whether you push the button or not. If you put power in this side, it would come out this side, whether you push the button or not. But terminal 1 and terminal 2 are not attached together unless you're pushing the button. Okay? So there's two ways you can do with this button. You can either send power into it, have a pull-down resistor, and then read that power on the other side. And when it goes, when it's at ground, when you're not pushing the button, the voltage will be 0. And when you push the button, the voltage will be 5 volts, and you'll get a 1023. But actually, we're going to do a digital read, so it'll either be 0 or 1. That's probably the clearest way, but it requires us to use another pull-up resistor and extra jumper cables, and it's really just not necessary because there are built-in pull-up resistors in the digital outputs. If you set them as input _ pull-up, then it will engage a pull-up resistor, and it makes the button work the opposite way, where now it's reading it as an input, but it's sending 5 volts out of that input, that digital pin, and so it's sending 5 volts, and it also sends it through its pull-up resistor to ground, so that does that for you, and you don't need to add it. And then when you push the button in, it provides an easier escape route to ground and doesn't go through its internal pull-up resistor, and so then it goes low. So instead of you pushing the button and it goes high, it's by default high, and when you push the button it goes low. And it's pretty damn easy to just change your programming to trigger on when the pin goes low as opposed to when the pin goes high. And it's simpler to deal with. You have less components and less jumper cables. So let's see. All we have to do this is send. We're going to use pin 2 here. You're going to skip pins 0 and 1 because those are used for serial communication, so you don't want to use those. And we're going to send pin 2, and we're going to send it over here to, here, let me make a better route on this. We'll send it on this side of the button. And I'll make this a nice, like, turquoise color. Right? And then this one just needs to go to ground. So I'm going to send this straight over to our little ground thing over here. Here, I'll make it, I'll do this so that it's a little bit more clear. Right, I don't need to send it all the way back over to the Arduino ground because this is already going to ground, so if I send it here, it'll go to ground. And I'll make that black. Okay. Then, in our code here, let's close the serial monitor for now, we are going to add the button. We're going to define our button pin up here. Const int button pin equals 2. Okay, then we're going to have our variable value here called int button state, right? Because it's going to have state changes between 0 and 1. And because its default value is high or 1, we're going to make its initial state 1 because that's when you're not hitting the button. All right, so button state equals 1. And then we have to set our pin mode here. We have this LED pin mode set up. We need to set up our pin mode button pin, comma, and this is going to be input underscore pull up. So that's an input mode that will engage that pull up resistor and energize the pin to 5 volts. And semicolon, don't forget your semicolon. Okay, now, next thing, we got our LDR value, we got our pot value, we got to do our digital read of our button state. So button state equals digital read, open parentheses, button pin, close parentheses, semicolon, digital read button pin. All right, so that will actually do that read of the pin 2 and see what its state is, whether it's high or whether it's low. Now we need to actually send that value out our serial monitor. So we're going to say here, serial print, a new space. So this is before the new line, right? So if you're doing literal spaces, I believe you use the double quotes. If you're using symbols like a new line, you use the single quotes. All right, so we're going to have another space, and now we're going to serial print button state. All right, that should work. All right, so this time, I'm going to do it properly. I'm going to verify my code. And it looks like it verified fine, so I didn't have any typos this time. So now I'm going to select all, copy it, put it in my Tinkercad, select all, delete, Velcro, start simulation. And there we go. You can see, again, we disabled blinking, but we have our LDR value that we can change by simulating the amount of light hitting the LDR. We got our potentiometer value. And now the button by default is 1, and when I click it, it goes to 0. All right, so let's do this for realsies. Here we are in the real world. Hey, the delay is a lot better right now. Let's hope it stays that way. Okay, we just need to add these buttons. So you may, I hope you don't, but you might have micro buttons, which are really, really small. And if you are like, if you have that, I'm sorry. It still will work fine. It's just a little bit harder to deal with. And I'm not sure how your buttons work, and you might have to rotate them by 90 degrees to get yours to work. But the way my buttons work, where is my button? There it is. Up, the delay's starting to come back. All right, you can see, you're like, which way does it go? Does it go this? Does it go this direction, or does it go this direction? Right? The wide, the short, the distance between the leg, the side that has the short distance between the two legs, those are not attached together. The side that has the long distance between the two legs, those are attached together. So generally, you use that long distance to span the gutter. That's why they make it that long distance, like this. So I have it spanned by the gutter, and if you push hard enough, it goes flush to this board. You gotta kind of push hard, right? So then all I need to do is connect this pin leg here. Maybe if I tilt it, you'll be able to see better. Yeah, this leg here to pin 2, and then this leg here to the ground. So let's do that. Do I have a long cable somewhere? What do I got? There's a long, running out of long jumpers. Here's a long orange one. It's not the best, but it'll work. And in fact, because, oh, and I want to unplug my Arduino before I do this. Because it's actually sending 5 volts off of this pin 2, because we have the pull-up resistor enabled mode, then it kind of makes sense that it's orange or close to red, because it is sending 5 volts. So that will go to that, and then the other one will go to ground. I don't have to send it all the way to the Arduino, because I can just send it to that same line that's sending everything else to ground. So this here goes, this here, that one goes all the way to ground. So if I put something on that same line, get my pin in there. There we go. Ugh, it's all wrapped around. There we go. And I send this all the way over here. Right? That should work. So this line here goes to pin 2, and that'll send 5 volts. When you don't push the button, that 5 volts will go through the internal pull-up resistor and will keep the pin set high. When you press the button, then that will connect it to this, that'll go to ground, and it'll send the pin low. Okay, so let's try this out. So here in my Arduino Ide, actually I can keep the video on the screen. And I click on Arduino here, and I need to upload this to my board. Oh, which I disconnected, so it's going to yell at me. It's going to say, I can't find it. Ah! All right, here we go. Let's plug it back in. And go away, Blink. I don't need you anymore. All right, let's make sure I still have the right board and stuff. Board, USB modem, yep. All right, upload it. All right, now tools, Serial monitor. There's my value. You can see it's at 1 because that's the default state of that button is 1, and when I press it, it goes to 0. And you can see how big the delay is in the video. Right? So that's the whole shebang as far as the Arduino side for this week. And I think what I'll do from here is let's just spend 5 minutes or so getting this value into TouchDesigner, and we'll save the actual like manipulation of a blobby sphere with this data for our meeting on Wednesday. All right, so this should only take a couple minutes. Open up TouchDesigner. I'm going to actually close this. We'll be recording to make my computer a little bit faster. And let's close serial monitor. Make sure your serial monitor is not open. And let's stop your simulation on Tinkercad if you're still doing it. All right. And now let's go and open up TouchDesigner. And hopefully, Touch will load and without crashing or taking forever to load. Come on, Touch. Oh, it doesn't like it. It is so slow. Come on, Touch. You can do it. Make a new file. It doesn't want to make a new file. If I disconnect my Arduino. Oh, there we go. Okay, great. All right, so get rid of everything here. Boom. All right. Now, we are going to use a DAT called the serial DAT. Serial. So I placed that. And now I have a message, and it says, could not connect by device project 1 serial 1. So I need to actually set this to the right device. How do I do that? Let's see. Well, first of all, here under baud rate, oh, I don't want to do that. I want this to be 11.5.200. Okay, and now port. I need to actually select the device from the port. And mine is USB modem 14201. If you have a PC, it might be COM3 or COM2 or some kind of COM. And there we go. Once I connect that, you can see I have scrolling away data from this. All right, let me zoom in. There we go. So those are actually all my data from the Arduino. And if I press the button, you can see that happen. And if I put my finger over the LDR, you can see that happen. And if I twist the potentiometer, you can see that happen. So now we got this data and it's ready to go. You see there is still a little bit of glitchiness. You'll see some weird values pop in here. And later I'm going to do some filtering to help try to keep those from getting into our system. I have found that it's difficult to 100% eliminate those glitches, but you can usually filter them out to keep them from affecting things. It's really just because serial messaging is not packetized data, so it's a serial string. So if the timing gets off through some sort of lag in the system, then it can mess up where the message is sent, or like how long the message string is. because it misses the end of line character or something like that. All right, so we are now going to send, we want to get just a single string out of this instead of a stream. And so we're going to send this through a select dat. Right? And we are on this select dat. We are going to, what do we do? Select rows all. Select rows by index. And we want to use start row index 1 and end row index 1. And there's our current value, right? Cool. I think that's all I need to do. I don't actually have it in my notes, but I'm pretty sure that's what you do. Yeah. All right. So we got that. Now we need to convert this to 3 different data channels. See, right now you can see this is in row 0 and column 0, and it's all 3 values. We want to separate that out into independent columns. So we're going to add a it's called a convert. Okay, and now we want to split cells at, right now by default it's a tab delimiter. We're going to use a space delimiter. So just put a space in there. It looks like nothing's in there, but there's an empty space in there, as you can see. And that delimitates that. And now you get 3 different columns. All right, okay, cool. Now, one last thing before we'll quit for the day, and that's to turn this into channels, so into chop channels. So we can right-click this and go from a dat to chop. And yeah, let's see, select rows all. I want to actually get channels. First row is values. First row is names. Is that right? No, that's not right. First row is values. Channel per row. No, we want channel per column. Boom. And there we go. Why is it only showing? It's probably skipping the first channel. So first row is ignored? No. First row is names? No. First row is values. First column is names. That's where it is values as well. There we go. Now we got all 3 channels. And I can do that. I can put my finger over this, LDR, and that goes down. And I can twist my potentiometer, and that goes down. All right, so now we have input into TouchDesigner that we can use to create an interesting thing, which we will do on Wednesday. And I will see you then. Have a great weekend, rest of your weekend. Have a great Easter tomorrow. And I'll see you on Wednesday.